Hello students, in this video we will discuss about local and global optimization. So in the last video we have discussed about the source of optimization, now how they have categorized, right? So that we'll discuss. So mainly we categorize the optimization into local and global that we have already discussed, and few of them we have already discussed from the local many times in the videos. So this will video is targeting about global optimization, right? So we have already discussed about constant folding, constant combining, strength reduction, constant propagation, common subexpression elimination in the previous videos as part of the people or as part of the source of optimization or transformations. So these we have discussed many times. Then how the same or some new techniques are going to be applied in global optimization, how the global dead code elimination is going to be done, all the global constant propagation, how the global copy propagation, global common subexpression, code motion. So this is only allowed in the global, right? Not in the, right? This copy propagation even you can perform it in the local also. And loop strength reduction, of course this we can apply in both. And induction variable elimination, again this is only for the loops, right? Then we'll go for the first one, global dead code elimination. See, a variable is said to be live, right, if it is used later in the program. For example, we use this live variable analysis or definition use, the chain where it is defined and what is used. For example, let me take this basic block. How many variables are defined here? R1 and R2. They are defined. And what are the variables we have used here? No variable, because we have used 3 and 10. Then same way, how many variables we have defined here? R4 and R7. We have defined it, R4 and R7. And how many we have used here? R1 and R4, which are on right hand side would be taken as used and left hand side are defined. Then we use the live variables to find the dead code. Assume that it is a bottom up approach as we have discussed. Assume that initially no variable is live, or assume that only R1 is live. So how you will come to know about it? From the other basic blocks. So as I told you, you have to find the live variables from each and every statement. You have to take everything from year to year if it is not on the right left hand side. Means R1 is here, then don't take it, and whatever you are having on the right hand side should be given. That we are telling to the previous basic block that see, R3 is going to be used later in the program. So if you are defining the R3, okay, just keep it, that is not dead, we are going to use later. That's what we are telling. Same R3, then here it is, then don't take it. Why? What we are saying that if you have any previously R3, that it is going to be dead. We are defining new definition to the R3. Earlier definitions are going to be dead. That's what we are saying. So don't take the R3, and whatever you are having on the right hand side must be here. So that we are saying that R2 and R1 are going to be used later. So if you have somewhere here, then don't delete them, like we are telling it. They are live, R2 and R1, like that. Then you can tell here same. See here R3 and R2 and R1 we are going to use. R3 is not used here. So R3 is a useless or dead assignment. If you assign here also, immediately that is going to be reassigned. That's useless. That's what we are telling it. So which are going to be used later in the program? R2 and R1, but not R3, because it is going to be reassigned. Then what are the live variables? Don't take here. So R2, R1 and R3, because R3 on the right hand side. So same way you can take it. R2 is here, then R1 only, because R2 is redefined. So you cannot take it. Then perform the union of these to get here. R2, R1, R3 and R1, it is nothing but R1, R2, R3. So same way you can find here before these two statements. So R7 is not here, right? Then you can take R1, R2, R3 and R4 also. R1, R2, R3 and R4. And here R4 is here, then don't take it. Then you can take R1, R2, R3. But again on our right hand side, then you have to take it. As it is left hand side, first we should not take it. As it is right hand side, you must take it. And here we are going to have R2 is there, then you can take R1, R3, R4. Then finally R3, R4 only. These are the live variables before and after each and every basic block. Then how can you identify the dead? See, you have to check the previous. R1 is here. So later in the program we are going to use. This is not dead. R3 is used here. So this is not dead. See, R3 is not here. Either it is not going to be used or it is going to be redefined. So this is called a dead assignment that we can eliminate it. Why you are saying that global? Because we are considering more than one basic block. Same way R2 we are using it, no problem. Then R7 is not here. Nowhere we are using it. So R7 is not here. You check it. If it is not here, then that is a dead. And R4, yes, here, no problem. And R2, yes, here. R1, here. So what is a dead assignment that you can delete from the code? That's what they're saying. R7 is not live and R3 is not live. I took a different one. That's why I got R3 is not live here. So if you take some other, we don't know what will be happen. Then the constant propagation, globally how it is going to be done. So we have discussed in a single basic block. Now we are going to discuss in a more than one basic block. Here R1 is 4, R2 is 10. Then we can propagate this 4 wherever you are having the R1. So you can write R1 is 4. From the same basic block you can take R2 is 2. So 4 into 2, directly you can say that R7 equivalent to 8. This is called constant propagation. Then R3 value is not defined anywhere, and R5, yes, it is defined as constant, but we don't know R3 whether it is constant or not. Then you can write R3 equivalent to R3 plus 2. That is a constant propagation. Same way you can just propagate the constant values if it is known to be constant with that context, that we can change it. Okay, but here you cannot take the R2 as 10, guys. You cannot. Why? I'll tell you. Sir, here R2 is 0 only. Why can't you take it? Means, see, the R2 is not constant with this context. For example, if I write R2 here, okay, for example, if I write plus R2, R5 equivalent 2 plus R2, then I can change this R2 to 10 because it is constant with this context. But R2 is not constant with this context. Why? Means, see, when you come from this place, right? So what is the R2 value if I come from here? So R2 is 10. Here we are not changing the R2. R2 is 10 here. Okay. Then when you come from the other way, for example, if I come from this way, so what is the R2 value here? Right, it is 2. So same R2 is one time 10, another time 2. So this is a variable, not a constant. That we cannot change it. That's what we have taken. Right, R7. See, whatever the way you come here, or you come here, the R7 value is 8. Then you can change it to 8. Right. So R3 is variable, because as R2 is variable, then R3 is also variable. Then we cannot change it. So that's how you are going to do the constant propagation. Of course, that is also use the def and use nation, whatever we have discussed. The next one, copy propagation. Guys, the copy propagation means if you have a variable assignment x equivalent to y, somewhere in your expression on right hand side, if you have a x that can be replaced with the y, that is copy is propagated to other. What is it? So directly the copy propagation doesn't affect on the code. Indirectly it leads to some other optimization techniques that we have already discussed earlier with the example. But okay, let me go with this. Here R1 and R2 copy, R3 and R4 copying. So wherever you have a R1 that can be replaced with the R2, wherever you are having R3 that can be replaced with the R4. So here see R3 R4, here I have R3, then I can make it R4. Right, same way here I have R3, then I can make it R4 and R2 R2. So you cannot do it. That's it. So what is the advantage of this by writing like this? See, for example, if you have a variable, live variable R3 here, then you can take it R3. Okay, so just we are making the use of R3 is 0. Usage count of R3 is what? 0. So that we can reduce the number of registers. So if simply copying from one variable to another variable and allocating a register to R3 is useless, right? So when you are simply copying the values, then replace the R3 with the R4 so that we can reduce the number of registers in the code. So next one, common subexpression elimination, right? So same here, whatever we have discussed earlier, like if the expression is common in more than one, then simply you can replace it. Like see here, you have R2 and R6 here, the common sub expression, and here also we are having R2 and R6. So simply you can replace it with the R1 if the R1 value is nowhere changed. But see, R1 value is changed here, then you cannot do it. You cannot. So that's what I'm telling you. You have to ensure that whether the value is not changed. Let me go with another one. For example, here R1 equivalent to R3 into 7, and here we are having R3 into 7. So whatever the way you come here, the R1 values remain unchanged and R3 values also remain unchanged. Then what we can do here, so simply you can replace this R3 R7 with the R1 R9 equivalent to R1, because that is not changed. Here R1 is not changed, R3 is not changed throughout this, then you can do it. But this, see, R2 R6 here we are having, and R2 R6 here we are having. But you cannot replace this R2 R6 with the R1. Assume that R2 is 4, R6 is 5, it is 20 now. But later it is changed to R3, is assume that some 5 value 35. We are changing 35. That is not going to be happen. So like that you have to consider more than one basic block also in this case. Next one, code motion. Moving the code from one basic block to another basic block. So here we are taking this index R4 equivalent to M5. Then every time when the loop is iterated, this will be executed, but irrespective of the value changed. Every time we are asking from the array, then this we can move it from the inside the loop to pre-header, right? Before the loop, okay, or before the basic block. So that we can take only R4 into 3 every time that is going to be happen, right? So then you may get a doubt that same thing is going to be happen in the loop. Yes, of course we can do it. So for example, here we can take it T2 equivalent to 4 into I, and we are not changing here, not changing here, not changing here, not changing here. I is not changing or not, right? We are every time we are changing the I value, of course, yes. Then I equivalent to I plus 1, then we can go for it. So this again we are coming back here, we are going to this, okay. Then what we can do here, we can move this code from inside the basic block to outside of it, so that we are going to reduce the strength of this loop. We are changing it to our T2 equivalent to T2 plus 4, whatever the application we are doing, that we are doing with the same condition. But this multiplication we are moving, but adding the plus. Loop strength reduction means we are doing the same with a different operator. So just replace expensive computation with the induction variables, which is going to be fixed. The star is replaced with the inductive variable, constantly increasing. Then we have an induction variable elimination also, that we have discussed in the last video. If you are having two variables, one for incrementing the loop, another one for assigning the array, the two things can be done with a indexing of variable like this. So here I check the condition of I greater than less than t1. So same thing I used it for the t2. Same, whatever the task I is doing, same thing is done by the t2. Right. So this we have discussed in the previous video with a clear our own program, not clearly, of course, with a own program. Right. So in the next video we'll discuss about the introduction to data flow analysis. That's the last concept of fifth unit.